All right, so the next part of the chapter 3.2 in your book starts with what we call linear regression. Linear regression. Okay, so linear regression, you can read the definition. A linear regression line is a line that describes how a response variable, y, changes as the explanatory variable, which is x, put parentheses around there, changes. We often use a regression line to predict. That's the big thing right there. That's what we're going to use it for quite a bit, is to predict. Predict the value of y for a given x. Sometimes it's called the line of best fit. You've probably heard of it. It's called the line of best fit. It's the line that best fits the data, right? Because our last set of notes, we had data like this, right? We had data like this. Not one line could connect all those dots, right? I would need lots of lines to connect all of the dots, right? Like if I wanted to connect the dots, that's what it would look like, right? But what best fit line or linear regression is one line. What one line is used to describe all of the dots, okay? So it would be a pretty much a line that kind of describes the trend, what's going on with those, okay? That's what we're gonna do. That's the first part of what we're gonna do. So how do we create that? Well, suppose that y is a response variable. It's plotted on the y-axis, and x is on the x-axis. A regression line has an equation. You've seen this equation before. Where have you seen that equation before? It's slope. Yeah, you guys have seen it many, many times with m's and b's, right? mx plus b. Where else? On your calculator, right? That's what we did last week, right? When we went to our calculator, we went to ln, reg, and then we went to this guy, right? A plus bx. That's where it comes from, okay? Yeah, the thing is, in other math classes, you use y equals mx plus b, right? In this class, they change the letters around. A is no longer, or sorry, B is no longer a y-intercept. It's actually the slope. Okay, B is the slope. A is the y-intercept. A is the y-intercept, which is here. Okay, so it's the same thing. It operates the same as y equals mx plus b. They changed the letters around. I have no idea why they did that. I think they did it because it fit the calculator, because our calculators don't use m's. So I think they did it to fit the calculator. So just make sure. You see B, it's not the y-intercept, it's actually the slope, okay? So the little y, it's got a little, like a little caret on top or a little like V on top. We read that as y hat. Y hat. Y hat, kind of looks like a tin hat. Okay, that's the predicted. That's what we predict. We use it to predict for values we don't know. Okay. All right. Okay, so to make it more confusing, sometimes our book used to do this. I don't think it does it anymore. I'm trying, let me see. Let me take a look. Our book used to use not A's and B's, but two B's, which I don't know why they do that. That makes it more confusing, but they do that. They used to do it. Let me see if they still do it. Let's see. Yeah, they do. Let's see. I don't think they use either. No, they do. They do use it. Okay, so our book uses these letters instead. Okay. Y hat they still use. Y hat still use. But instead of A, they use B sub 0. That's the y-intercept. And slope is B sub 1. Okay. So instead of just A and just B, like our calculator uses, our book uses these notations. They mean the exact same thing. They just use different letters. Why? I have no clue. I have no idea why our book uses these notations instead of the same one our calculator does. I can't tell you why, but I'm just telling you they do. So if you see B sub 0 in your book, that means the y-intercept. Our book, the book is the same people who write the tests. So those tests I give you, That comes from the book. Okay, so if they use it there, I'm guessing they're going to use it too on your test. But just when you're using your calculator, they don't use those. They use A instead of B sub 0 and B1. So it's just, that's why I put it in your notes so that you could keep it there. So your calculator uses this up here. Your book uses this one down here. They mean the exact same thing. The only difference is A, in your book, they don't use A. They use B sub 0 for y-intercept. And your calculator uses B for slope, but the book uses B sub 1 for slope. Okay, why? Like I said, why? I have no clue, but I just wanted to let you guys know that because you're like, where's A? Or what is A? Well, look there. Okay, all right, so we're going to use the data we've already used before to create one. We've already graphed this guy, right? So get your calculators out. I'll show you how to do it on a calculator. Okay. All right. So go look for this data in L1 and L2. If it's your calculator, it's already there. If it's not your calculator, it may be there, it may not be there. Because we used it on Friday, but if someone else used the calculator, I might not, I don't know. Okay, so if it's not there, we need that in L1 and L2, just like we did on Friday. Let's see. So first thing, go check. Go check L1 and L2 to see if it's there. If it's not, type it in. Be right there. Okay. So once the numbers are in there, we're going to do the same thing we did to find R. Last week when we found R, we're going to do the same thing. Same calculator maneuvers. Okay, so to do that, we started at stat, right? I went over to calc, and then I looked for the one that says A plus BX. Linreg A plus BX. Not the first one, the second one that says A plus BX. That is the one we're going to use. Okay, that's the one we use for statistics. Okay. It asked me, what is your explanatory? Well, my explanatory was miles driven. That's an L1 for me. For you, it might not be. For me, it's an L1. Okay. My price was in L2. That's my response, right? So I make sure I tell it there. If it's not, if you put it in some other list, just change L1 or L2. Okay. Then I just hit enter a bunch of times. Enter, 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 calculate. And there appears A and B. R's down there too, but A and B is the one we need. Okay, so I'm going to write those numbers down. A is 773 and 284. On paper. 284. B is negative 0.086. Always go 3 spaces past the decimal unless they tell you not to. So I wrote down A and B up to 3 places past the decimal. I just wrote it down on my paper. It's not asking me to, they don't tell me where A and B, I'm just writing them down on my paper so that I can answer the question. Okay, so I just wrote them down at the top. I wrote them down right there. Okay, so I don't have to flip back and forth to my calculator, and because if you hit clear on your calculator, then you have to calculate them all over again. That just takes time. So I just wrote them down. Okay. Okay, so remind me, what is A again? What does A represent? What does A represent? Y-intercept. That's the y-intercept, right? What does B represent? The slope. Okay, so I'm going to put all of those together. Now, don't write this down yet because you notice this says right here. This is the most important part right here. It says in context. In context means with our situation, miles driven and price. Okay, so miles driven. Which one is miles driven? X or Y? X. Price is Y, right? That's what we said earlier. That's what we said last week, and it's still the same. All right. Okay. Why does this guy have a Y hat? What is Y? I know what Y is. Y is price. But what does the hat mean? What does the hat mean when there's a hat on top of the Y? Say it. It's the predicted value. It's not the actual value. The actual value is listed here, right? Those are the numbers. It's the predicted value, right? So when we write this down, we're going to do this. Y equals A plus BX. Except I'm not going to use A, B, Y's. Those A, B's, and Y's, I don't want them to be A's, B's, and Y's. I want them to be what they really are. Oops, sorry, that's Y hat. So I'm going to start with Y hat, predicted price. Predicted Y value. That's what it is. It's the predicted Y value. So it's the predicted price. Predicted price. It's not the actual price. Those numbers are over here. Okay, it's the predicted price. That's why it's got a little hat on it. A is a number. Don't we know what A is? They told us A is right here. All right, so this number here, I'm going to move down here. Oops, nope, I don't want that. Put it right there. That's what A is. Okay. Plus B. B, I know that number again too. I know that number too, right? That number is right above it. It's negative 0.086 times X, right? That's what it means, times X. I don't want an X. I want an actual name. What is it? What does X represent? What does X represent? Miles driven. So instead of X, I'm going to put parentheses, and I'm going to put miles driven. Close parentheses, I'm done. I don't have any A's, B's, X's, Y's. I don't have that like you do in a regular math class. I have what they actually mean because they actually mean something. Each of these actually mean something. X and Y always mean something in statistics, right? So that's what I mean by in context. I know what my Y hat is. I know what my X is. I know what these guys are. You've labeled A and B in there. Okay. So that's what I mean by in context. Okay. Okay, so the next one wants me to interpret slope. So I'm going to rewrite it in here. Negative 0.086. Okay, that's the number. How do you interpret it? I put a little sentence frame in here for you guys. A little sentence frame, which you just fill in. So we start it. The underlined stuff is the stuff you change. If it's not underlined, you rewrite that. So we start for every one explanatory variable. What is the explanatory variable? Miles driven, right? So for every mile drove, or every, it's bad English to say 1 miles driven, but you could say for every 1 mile driven, is that, or drove or whatever, for every 1 mile driven, comma, next comes the response. What is the response? The price. So this one we're going to pick one, increases or decreases. It's always going to be one or the other. How do we know if it increases or decreases? Yeah, exactly. If our number is negative or positive. So B is negative, right? So that means it's going to decrease. The price decreases by, and then you give the actual number. Now, I don't write a negative number here because I already said it's going to decrease. So I write the positive version of it. Yeah, because if you say something decreases by a negative, you're actually saying it's increasing. Yeah. It's like saying minus a negative. That's adding. That's actually adding. Yeah. So if you say, you can say increases by a negative number, or you can say decreases by a positive number. Either one is okay. You just can't say decreases by a negative because then that's double negatives. Okay. Okay. So the slope, 1 mile, right? So we labeled that. Slope. What is slope? What type of units does slope get for this problem? Not cents. It's going to end up being that, but what are these over here? Dollar amounts, right? So dollars. It's going to end up being change, but we don't want to put the cent symbol. We want to put the dollar symbol. Okay. So what does this mean? It means every time you drive this car 1 mile, you're losing about 9 cents. Every time you drive your car, every time you drive this specific kind of a car, whatever, CRV, you're losing 9 cents for every mile you go. So if it takes you 10 miles to get from here to there, in 10 miles, you lost almost $1 just by driving it, right? That's what cars are. Cars lose value. They lose value every time you drive them because we talked about this on Friday. They're based on miles driven, okay? So every time you drive this car 1 mile, you're losing about 9 cents of its value. That's what it's saying, okay? All right, so now let's do the y-intercept. That number is a little bigger. 1,8,773, decimal 284. Again, I gave you a little sentence frame. So whether underlined, you're going to put in your own word. So when explanatory variable, what's the explanatory variable here? When miles driven is 0 or equals 0. Response variable, what is the response variable? Price is that number. So we say when miles driven is 0, price is, we got a label. You got to label with correct, since it's dollars. And since it's dollars, we probably don't need that 4 at the end because pennies, we don't go past 2 places with money. It's not wrong if you put it there, but just to be a little more correct. So when miles driven is 0, the price is $18,773.28. What does that mean? What does that mean in more plain English? If it's a brand spanking new car, has never been driven, it's going to be about $18,773.28. Okay, that's what it's saying. Okay. All right, so the reason we use the equation of least squares regression line is to predict. So the next question says predict the value. I don't have a car over here that's 50,000 miles driven, right? There's no car on my list that's 50,000. I have one that's close, 49,000, but there's a big difference between 49,000 and 50,000. It's 1,000 miles driven. 1,000 miles, that's a lot. Okay, so I can use this guy to come up with my price. Okay, so I'm going to use the equation. Predicted price equals 18,773.284 plus a negative 0.086. But instead of miles driven, I'm going to put in 50,000. What do you get? So you multiply, then add. When you do that, what do you get? 14,000. Say it again. 14. How much paint? How much pennies? 2.8. There you go. Always check to see if that makes sense with the data you have. 50,000 would be right in here. Right? So we would expect it to be a little bit less than that, but a little bit more than that. That's right. Makes sense. So if I have a CRV that's been driven 50,000 miles, I would expect to get around $14,473.28. That's what it would sell for. So if I took it to a dealership, would I get that? No, because the dealership has to make money on top of that. So they're going to give you less than this. But if I'm selling it private to someone, not a dealership, then this is what I would, that's how you price cars. That's how they price cars. How do they come up with these numbers? That's how they price cars. You can't sell your little jalopy for $50,000. That's not how it works. If you have the car I had in high school wasn't that nice. If I tried to sell it for $50,000, I wouldn't get anything. I wouldn't get that. Okay, you have to do research based on what others have sold it for. Okay, and that's how you come up with the price. Okay, all right, so do the next one. $250,000 CRV, a Honda that has $250,000 or miles on it. What would that get? Okay, so now we got to predict the value of a used CRV with 250,000 miles. So we're going to use the same equation we just used. So predicted price is going to equal 18,773.284 plus negative 0.086 times, instead of 50,000, we're going to plug in 250,000. So we're going to multiply these two guys first. And then add 18,773.284. And we get negative 2726.72. That'll also be in dollars. So the next part of the question says, how confident are you in this prediction? Well, I'm not very confident because it's a negative number. When you sell things, you always get money. Like for this question, if you sell it, you would sell it for $14,473.28. Here it's a negative number. So what that means is you're literally paying someone to take it. So that's not selling. That's giving it away plus giving them money on top of it. That's not how things work. So how confident are you? Not very confident at all, because that's not possible. Either it's worth something or it's worth $0. So this number can't go below 0 in real life. So I would say not confident. And the reason I'm not confident is because if you look at this value here, 250,000, and I go look at my table, there's nothing even close to 250,000. The highest number is 86,000. 86,000 compared to 205,000, 250,000. If I had that number on my list, it would be somewhere down here. So that's what we call extrapolation. It's called extrapolation. Extrapolation means taking the data sets that you have and plugging in or using a number that's outside of that range. So my range goes from 22,000 to 86,000. That's my range in miles driven. I don't have anything close to 250,000 miles. So I would be comfortable predicting for any car between 22,000 and 86,000. For example, the one we just did, 50,000. I would be perfectly comfortable there. But anything above 86,000 or below 22,000 is something I wouldn't be confident in because I don't have data within those. So we would call that extrapolation. 50,000 is what we call interpolation. Interpolation means it's within the data. It's in what's in the data, to be right about there. Okay. So this is what the picture looks like based off the graph, based off the scatter plot, right? So the scatter plot, you don't have to number it. You just have to give me a general idea. Does there have to be exactly 31 dots there? No, just come close. Okay. Give me the general pattern of it. Label the x-axis. The x is shoe size. The y is height. Label those. That's all I need to see. That's drawing and labeling. It is on the back, yeah. No, so what they wanted to tell is if your shoe size told anything about your height. So if I know I have a person who's 11, who has a shoe size of men's 11, does that tell me that they're going to be tall or short? That's what they're trying. That's what they're trying to do. They're trying to see if there's a relationship between the two. Okay. Okay. So R for R. When I plugged it into my calculator, I got R equals 0.37. Okay. Three things when we're interpreting R. One is strength, one is direction, one is linear relationship or linear association or linear correlation, something like that. Okay, so 0.777 is definitely positive. So you say there is a positive. What would this be considered? What strength would this be considered? Moderate. It would be on the high side of moderate, but moderate's fine. You could put moderate. It definitely include the word moderate. Not positive to strong. I would say if you said yes, that's okay. Moderate to strong is okay because you use the word moderate. You definitely want to include the word moderate. But some people are like, you know what? It's on the high side. It's almost into strong, so I want to include strong. That's okay. But definitely you would include moderate. Okay? There is a positive, moderate, or moderate to strong, linear, relationship, association, correlation, whatever you want to say. Okay? Equation, here we go. So instead of y hat, right? Instead of y hat, that's predicted. Predicted what? Predicted y. Well, in this case, the y was height. So predicted height equals, and then it's A plus B X. Well, instead of X, we're going to write the words shoe size. No X, no Y's, no A's, no B's. I have them all filled in. That's means in context. Okay. Calculate the slope. Well, I already did calculate the slope. The slope is 1.462. How do I interpret it? You use your sentence frame I gave you. For every one explanatory, for every one X, for every one X, X in this case is shoe size. So for every one increase in shoe size, or wait, I'm going to write increases later. Shoe size increase, what does it say? The response variable, in this case is the height. Height increases by our number, 1.462 inches. So every time your foot grows every time you're based on the data, every time your foot grows a full size, you're going to get about 1.5 inches taller. Makes sense. Okay, last one. A is 54.071. That's the y-intercept. Interpret it. All right, well, I'm literally going to copy the sentence frame I had on the previous page. When explanatory variable is 0, explanatory is X. X is shoe size. When shoe size is 0, response variable, height is 54.071 inches. When you have a shoe size of 0 in men's, you're going to be 50.071. Does that make any sense? No, but it still is. That's what it means. So a lot of these won't make sense. That's like a baby foot. Like a 0 in men's is like a baby foot. It's not even a men's size, right? That's what it says. Sometimes they won't make any sense. Sometimes they won't make any sense. Trust me, I know. But this is how you interpret it. They always want you, if they say interpret it, interpret it. If it doesn't make sense, it doesn't make sense. It's okay. All right? If it doesn't make sense, it's okay. Just interpret it the way they want you to. Okay? All right. We're going to stop right there. We're going to stop there. We'll continue on